Alright, there we go.
Alright, so now we can go ahead and try and figure out what other information is given in this problem. But remember, so long as we can confirm that we're launching something horizontally, these 7 things always have those values. And I think it is valid that this marble is going to be launched horizontally, because most tabletops are like horizontal, right? So when it first leaves the table, it should be just moving horizontally. So we have 3 other values that might need to get filled in over here, and then we have 1 unknown. So let's read carefully and convince ourselves that we know what these other 3 values are. Melanie rolls a 10-gram marble. Down the ramp, it has a horizontal velocity of 1.2 meters per second, and it falls in a cup placed 0.51 meters from the table's edge. And then how high is the table? So the final horizontal position, is that something that we know? Yeah, we do. The cup is 0.51 meters from the edge of the table. That's how far this marble is going to move horizontally while it's flying through the air. So if this is our marble right here, right, it rolls off the tabletop here, the 0.51 meters is a horizontal measurement. So absolutely, that goes right here, 0.51 meters. Do we have any idea the amount of time that the marble is in the air? No, we have no idea. It's not actually what we're trying to solve for either. So I'm just going to leave it blank. I'm not going to put a question mark or anything. Do we know the horizontal velocity? Yeah, we do. And the language is very clear. Horizontal velocity up, right? There's no covert language there. So that is 1.2 meters per second. What about initial vertical position? Is that something we know? Shruti?
Why would the final distance be 1.51? Because, like, isn't it going down the ramp?
Yeah, so that's interesting. The ramp is actually up here. And then it doesn't become a projectile until it leaves the table. Actually, better yet, the ramp is like back here, and then it rolls along the table. So the 0.51 meters is the distance from the edge of the table to where the cup is. That should be a horizontal thing. Yeah, the ramp is like up on the table. Ask a follow-up, because there's something not clicking still.
Like, I'm kind of confused because, like, when it rolls down the ramp, doesn't it also have, like, doesn't it start moving when it's on the ramp?
Yes. So up at the top of the ramp, presumably it's motionless. It rolls down the ramp, builds up speed, keeps that speed as it travels along the edge of the table, and then it becomes a projectile. But whatever speed it gained while going down the ramp, that's the speed that it would have as soon as it, as it leaves the table. It would still have all that speed, and that's the 1.2 meters per second. So you're right, it attains that by rolling down the ramp. All right, initial vertical position, do we know that? No, but that's exactly what we're trying to find, right? How high is the table? That's the same thing as what is the initial vertical position. That's a vertical thing. That's what we're trying to solve for. We still don't know the final time. We already addressed that. We don't know that yet. What about the final vertical speed? Do we know that? No, we don't need to know that either. All right? So we put in 2 additional values. We put in the horizontal velocity, and we put in the final horizontal position. And we did identify that we need to know the initial vertical position. Follow-up questions about the 2 other variables we put in, or the unknown that we said we're looking for. Jane?
How do you know when you don't need the other variables?
Well, I might need them, but it's not what we're ultimately trying to solve for. Right? But you're right, we might need to find something in order to get this. In fact, we will. Holly?
Wait, do you just need like the questions?
If it's not what I'm specifically asked to find, then yes, I just leave it blank.
Okay.
That way, it's my way of accounting for, hey, this is what I need to focus on. This is what I need to care about. Anything else is incidental. All right, so what the heck? Do I have any equation that would allow me to find this based on the other stuff that I know? Well, I know 3 equations. Actually, I know about 4 equations that deal with this kind of motion. One of them is average velocity, is the displacement over the time interval. Can I use that one to get this? No, because I don't know the time. I don't know the TF, right? So I can't use that. One of them is acceleration, is the change in velocity over the time interval. Can I use that one to get this? No, it's not even there. Like, how can I use that to find it if it's not even variable in that thing? Well, what was the next one? VF equals VI plus AT? And that was the third one in your equation sheet. Are we going to be able to use that one? No, it doesn't have initial position in it. No way. What's fourth? Is it the DF one or is it the VF squared one? DF one? Okay, can I use that one? It has DI, so I can use it, right? No, I can't use it. It doesn't. We still don't have the time, right? Oh no. Well, I only have one more. So I can use this one then, yes? No. No, I don't have the final vertical speed. So what do? I can't solve it? No, I can. No, I can't. But I don't have enough information in the vertical direction. Maybe I can get some information from, well, maybe really what I'm going to do. I know everything there is to know horizontally except for the time. And if you remember, it was the time in one of these that was the only thing that prevented us from being able to use it. So my process here is going to be use horizontal stuff to find the time, and then I can use that time to find out what I want to find vertical. And that's precisely what I'm going to do. So we said earlier that really the only equation I ever use in the horizontal direction is this one. So that's exactly what I'm going to use. And I'm going to do this on my paper, when I'm doing this in my notes, when I'm doing this on my test. I'm going to do the equations directly underneath the variables. So since I'm doing this in the horizontal direction, I'm going right underneath my horizontal variables. Okay, so the horizontal velocity is the horizontal displacement divided by the time interval. I know everything in here except for TF, so I can put the things in. The average velocity in the horizontal direction, we have a constant velocity, so I can certainly call 1.2 my average velocity. The final horizontal position is 0.51. The initial horizontal position is 0. The TF is what I'm actually trying to find here, and then the TI is 0. So I suppose as my next step, I can just get rid of the zeros. I'm going to shift over here. Right, so 1.2 equals 0.51 over TF. My next step would be multiplying both sides by TF. So now if I just kind of reverse this left-right, I have 0, I don't even need to do that. TF times 1.2 equals 0.51. And my final step to find the TF would just be to divide both sides by 1.2. So I'm going to go ahead and find that on my calculator. I don't want to round it too much yet since I'm going to use that for other stuff. But once I get that, then I'm only one equation away from solving the problem. Now, this should have 2 significant digits. Normally, I would keep 2 or 3 extra, but my calculator says exactly 0.425, so I only need to keep 1 extra digit. That's all there is. All right, follow-up questions about using this horizontal stuff to find the time. All right, well now, I should be able to use our big, long DF equation to find the initial vertical position. Alright, so DF is 0. DI is what I'm trying to find. I just leave that alone. Oh, VI is 0. That's great. It's great when we have zeros mixed in. TF is what, I know that. TF I just found is, what was it, 0.425? Yeah. The acceleration is negative 9.81. And then the time is 0.425. And that has to be squared. Alright, so as a next step, I suppose I can just totally ignore this term, right? 0 times 0.425 is just 0, so I'm just not even gonna, yeah, I guess this time I'll just put in plus 0. And then I can go ahead and get this whole term. So 0.5 times negative 9.81 times 0.425 squared. So that's negative 0.88597. That should have 2 significant digits. So 0 equals di, I can go ahead and round now, I'm not really doing anything else. 0 equals di minus 0.89. And then my final step to solve for di would just be adding the 0.89 to both sides. I'm going to have to move over though to do that. And if I'm adding 0.89 to both sides, then di should be equal to positive 0.89 meters. So this table must be 0.89 meters above the floor if that marble is going to land on this cup, in this cup, 0.51 meters away. I'll give you a little hint, right? Any time for these projectile problems that we don't know the time, that's almost always our starting place, is to use one of the 2 directions, whichever one we know more information about, to get the time, and then hopefully we can find what it is we're trying to solve for once we have that. All right, so I'm just going to turn off the thing. I'm happy to handle if there's a question or 2 about this, and then I'd love to start looking at a second one with you, but then give you time in your foursomes to try and